Welcome back to our tutorial series about deploying a Django app into the cloud or into a Kubernetes cluster. Today in this video we're going to take a look at what we want to do with Kubernetes, what we need to do that, and also at the first couple of YAML files. So in the previous tutorials we've made sure we have a proper Docker image, actually a full Docker Compose setup here. And we optimize the size and the speed of building that images, which is helpful for the tutorial video, to be honest. And today we actually write deployment YAMLs, so to say, for Kubernetes. All right. First, let's take a look at what we want to build. I have a picture here that should explain it all to you. Basically, we have our Kubernetes cluster and we need to add deployment and services. These are basically YAML files. It's not the whole truth. We also need to add secrets and volume definitions. So let's actually start at the very back. In this case here, we actually will need a Postgres deployment, which will spawn a Postgres pod. And that deployment needs some secrets, so the username, the password for the database, and it needs a volume and a volume claim, so to say, in Kubernetes. The same is true for RabbitMQ. RabbitMQ will need a secret and a volume and a volume claim, so that's this part here. And in the end, we will need to connect to that database and to that RabbitMQ server. Although the arrows here don't indicate that we connect to something, in fact they just indicate that we're using the secret. So the Python Django deployment we have here, I have a deployment with 2 pods in here. So this is like replica count 2 if you are familiar with Kubernetes. If not, it's just like we just scale the container up to 2 instances of it. And the same is true for the Celery deployment down here. We have 2 pods, 2 instances of the Celery deployment, or of the Celery pods. It's one deployment with 2 pods. And those deployments need to be aware of the Postgres and the RabbitMQ secret. So that will also hold maybe the IP address of the container or of the Postgres database. Because in the end, nobody tells you that you need to have your Postgres and your RabbitMQ services within Kubernetes. They could be external. That could be like a service offered by Google or by other providers that you get a database with an IP and password and username and you just add the secret. So with that, we add some flexibility to our deployment. I know I've talked about the .env files in the last video. That's fine. We can also use them. But in the end, the idea was not to use .env files for everything, but to use environment variables. And those environment variables, they can come from a secret, basically. So we'll see that when we write the deployment YAML. Anyway, the main difference then between the Python/Django deployment and the Python/Celery deployment is that the Python deployment also needs to be exposed to the outside via a load balancer, via ingress. We're going to use load balancer with minicube tunnel in this little tutorial. If you have a DigitalOcean service or a Google Cloud Engine Kubernetes service, or you use Amazon Kubernetes service, I think it's called EKS or Azure, whatever, you most of the time will get a load balancer with it. Just be aware that there might be some cost involved in using an external load balancer. With minikube, we're being on our local machine, there's no cost involved. There are some restrictions to that, obviously, because we can't easily just set a host name. We will have to use the IP address of our minikube service locally. So that's beyond that tutorial, but if you go to any public service, you can use a host name. If you're interested in actually seeing what this would look like on a public service, like I have some DigitalOcean experience, we can make that in another video. Just let me know if you want that in the comments, and if you see that, upload it or whatever. We'll figure out the way that we can make that video then. All right. So now that we got that out of the way, let's actually start our minikube server. Minikube, I have it installed already. I'll put a link of minikube in the video description, or you just Google it. Basically, when you got it installed and set up, you say minikube start, and it will spawn up something depending on your system. I've got a pretty good system, so it's using 4 CPUs and 8 GB RAM on my system. It's using KVM. I could also have used VirtualBox as a driver, and while that one is spawning up, it takes a minute or two because it's spawning up a virtual machine. We will just do something else in the meantime. So what do we do in the meantime? We need to take a look in our repo. And what I like to do here is I like to create a new folder called deploy or Kubernetes or whatever. Let's call it deploy. And in that folder, I like to add like all my deployment files that are needed to deploy all my services. So in this case, I'm gonna use one folder called Postgres. We're gonna add a new folder called Python. It's kind of similar to what we have, well, not quite. We have like that structure here in our Docker container or a Docker folder where we have Python and Nginx. By the way, we won't need Nginx because this is already handled by our load balancer here. So we are going directly into the pod, connecting directly to the pod where Unicorn is running. But yeah, we're trying to make that same structure. And we don't want to have dev and prod right now because for Kubernetes it doesn't matter as much as it does for Python. So we're gonna just have that as our deployment. So actually I forgot something. I lied. We also need RabbitMQ. There we go. So the nice thing now is, now that we have everything set up using Kubernetes and actually Docker, we can reuse the Docker images that we have in our Docker prod, for instance, and we can reuse them. But we'll get to that later. First, I want to start with Postgres. Actually, let's take a look. It's still booting up. So it's telling me it's preparing Kubernetes now on Docker or something. So there's a Docker host actually also in my VM, but we're not going to use that directly. We're just gonna assume that we have a public Docker image available that we're gonna run. All right. First things first, let's talk about Postgres. So as we've seen here, we need a volume, we need a secret, and we need the Postgres deployment. This is something, if you Google for it, you will find like a ton of tutorials how to get Postgres into Kubernetes with Google, with DigitalOcean or whatever. So what I do here is just one example, one way of doing it. It's not the way of doing it. Although I'm gonna just claim that it's pretty close to what you should do. But again, just feel free to Google for some other tutorials and compare them. The first thing that we will need, So the first thing that we will need is Postgres deployment, Postgres storage YAML. So in Kubernetes, we need storage. We could do without storage. That's although not quite a good idea. This is like, imagine you start a Docker container, like Docker Compose we have here with Postgres, and it would be started without that volume in here. This would lead to a huge problem because every time you start the container again, you would get a fresh PG data volume, well, not volume, but directory, and you lose all your data. So we need to start with a storage in here. And that storage is a persistent volume. So that's what you need to write. And you need to have some metadata so we can reference them later. That's fine. I don't think you need to specify the volume all the time. I think the volume that we specify here is just for minicube. So minicube knows the storage class is manual and we give it like 100 megabyte of capacity. You can also write there 1 gig, but we need to have like the volume specified somewhere. And what's also very, very specific for minicube, you need to define a host path. So this basically means minicube doesn't come with storage built in. It just puts the data into the virtual machine's data directory. If you spawn up a new minicube VM, you lose all the data. All right. You also separate, if you have multiple things in one YAML file, you separate them by the 3 hyphens. The next thing you need is a persistent volume claim. And in this volume claim, we are also giving that volume claim a name. We have some metadata here. We say this is like our Postgres app. Okay, fine. And it's kind of redundant. I don't know if you need to do that, but I think it is required. You need to set the storage that you request in the claim again. Because I think you can have like 200 megs here and then request 100 megs of it down here. So this is like our limit by our provider. And the one below is what we actually want to use right now. And with that, we can actually take a look. Is our minicube up? Yep, minicube is up. So what we can do now, first of all, we can double check if minicube has configured everything properly. So we're gonna use kubectl or kubectl, whatever way you like to call it. I'm gonna say kubectl all the time. We can say kubectl get pods. It will tell us there is like no pods in the default namespace, I hope. If you already have some deployments or pods, whatever, in your cluster, doesn't matter, it's just an example. Okay, no resources found in default namespace. We can also say get nodes, I think. Then it tells us we have one node, it's called minicube, it's ready. It has also the master role, it's 2 minutes old, and it uses Kubernetes 1.16.2. Fine, cool. So what we do now is we want to apply this YAML file. So we're gonna go into deploy Postgres, and we're gonna say kubectl apply -f Postgres storage YAML. And it tells us the Postgres PV has been created, the volume, and the claim has been created. Okay, we can verify that by saying kubectl get PVC, and there we go. We got our Postgres PV claim, 100 megabyte, and storage class manual. Cool. So that's our storage. That's fine. The next thing we're gonna do is credentials. So we're gonna create a file called postgres credentials.yaml, and this file is also quite easy. A credential is basically a secret in Kubernetes, and it has some metadata, again a name. We also add the label app Postgres to all of that so we can reference them in between. And the last thing you need in here is user and password. And now the main problem is you can't just say user like Postgres and password my password in here. That's not gonna work. What we need to do here is we need to add a base 64 encoded string. Now you're gonna ask how am I gonna get a base 64 encoded string easily. Obviously you can Google for it, or you can use this neat little trick on Linux, and I think it should work on Mac. Use echo, for instance, Postgres, or let's actually call it my Postgres user, and you're gonna pipe it into base 64. So what that should do for us is it should create a base 64 string. Please mind there might be an equal sign at the end. You need to copy that too, but we can copy that string and we can put it in here. And the same is gonna be true for password. I'm just gonna use my password in here. It doesn't have an equal string in the end for probably the reason that it's shorter. It's how base 64 works, not gonna go into detail. And yeah, last but not least, we need to also apply that secret. So we're gonna say kubectl apply -f Postgres credentials. It will tell us the secret has been created. So we're gonna do kubectl get secrets. Then we have like the Postgres credentials here, and we can also say get secret Postgres credentials. And we can say -o YAML. And if we then scroll up, there's the command again, kubectl get secret Postgres credentials -o YAML. -o is for output, YAML is the output format. Then we get the data field here, and this is again our secret. And if we copy that, you might ask how you're gonna get like the actual name of it. So you can say echo this base 64 decode, -d is for decode. And will tell you the name is my Postgres user. That's just one thing that I think that I've done wrong right now. I think I should show that. If we do it like this, we get this result. And if we do it like this, with -n, I think, yep, we get this result. There's one letter less, or is one letter that's changed. So what is the difference between echo and echo -n? Echo -n will not print the new line character at the end. So if I do it without -n, there we go. We get the new line character in the terminal, but we need to do it without -n, with -n, sorry. And we need to pipe that into base 64. If you don't do that, you get a very weird error message sometimes. It cost me a couple of minutes to figured it out, unfortunately. Anyway, this is what this tutorial is for. So echo -n my password pipe into base 64. Great. I think that one hasn't changed. Okay. So what do we need to do now? Because we've changed our credentials, we need to apply them again. So I'm gonna find the command again, kubectl apply -f Postgres credentials, and it says is change the credentials. Cool. And we can do get secret -o YAML again, and we should see that it has changed them. Yep, just changed them to what they should be, and we can copy it again and again. Try echo, oopsie, echo this pipe into base 64 decode, and what you now see is it has decoded, and there is also no new line string in here. So this is what we want. All right, so now we've got the credentials, we got the storage. All we need now is a deployment, and for that we're gonna create a Postgres YAML. You can also just call it Postgres Deployment YAML, but I'm kind of trying to create a system here where we want, like, this is our Postgres YAML, this is our entry point for Postgres, and this is what we need in addition to get Postgres running. So the deployment basically starts with kind deployment and some metadata again. Then we need to have a spec. The spec will tell us there's like one replica. We don't want more than one replica in this case with Postgres, for a very simple reason. We only have one persistent volume. If you want multiple replicas, we need multiple persistent volumes, one per replica, so to say. Or we need to actually use a better Postgres image than the base image that allows us to scale up. This one just doesn't, so that's why we leave it with one replica. Then we're gonna add some more things. Basically, it will have a template. So this is the spec for the deployment, and each deployment has a template which has a spec again. And in that spec, we define which containers we want in our deployment. And the first container, or the only container we want, is our Postgres container. And that's very similar to what we use with Docker now. And here we just say we want Postgres 10.4. Let's verify. Okay, we have Postgres 10.3 in here, so in our Docker Compose. So you know what? We're gonna use Postgres 10.3 here for the sake of being consistent. And we need to tell Kubernetes that we want to use the container port 5432, because this is the port that Postgres is opening to us. Alrighty. And now comes the actual funny part. Environment variables. We need to have an environment variable that's called Postgres user. Just to double check. There we go. It's called Postgres user in our Docker Compose YAML. So it's gonna be Postgres user in here. And we could actually just say value is my Postgres user. I think it's without the, no, it should be fine. We could just say that it's my Postgres user. I think I have some errors in my YAML file. Bad indentation, I think. Maybe. Oh, that one. I think ports needs to be on the same level as this one. Yeah, same with environment. There we go. So I could just have this one in here. But you see, there is an immediate problem that arises from this. If you have Postgres user and Postgres password like this in here, and it's like my password, and you add that to your Git repository, which is fine. You should add your deployment YAMLs and all the other YAML files to your Git repository. But if you do that, imagine it's a public Git repository like we have in our Django upgrade video repository, then everybody knows my Postgres username and password. That's not the way it's intended to work. And this is why we can use, instead of value, we can use value from, and we need to specify, I want to have the value from the secret key ref, and it's called Postgres credentials. Let's double check that. It's called Postgres credentials, and we need the key called user. So here we say key user. And the same is gonna be true for our password. We want the password from our Postgres credentials, and the key is password. All right, so last but not least, this is fine, but last but not least, we need to specify the Postgres database. Let's double check Postgres DB. This is something we haven't specified in our secret, but I think that's fine. This is not a secret in my opinion. You could use it as a secret if you really want to, but we don't need to. So we're not gonna use value from, we're just gonna use value, and we're gonna call it, what did we call it in here? Need to look in the .env file. We called it tickets. So we're gonna call the database tickets as well. There we go. And we have some errors again. Oh, sorry, it's key is password. So there we go. If you use PyCharm, it's quite nice. You get like that info. All right. So what's left to do is to apply this YAML file. Apply -f postgres.yaml. Hold on. That was way too fast. What we haven't done yet is we haven't defined the volume. So we need a volume mount. There we go, volume mount. We mount in the volume into varlib Postgres data. And we need to tell Kubernetes that we want to use the Postgres volume mount with the Postgres PV claim that we've created. So that is now enough. That's good. All right. If we do now kubectl apply -f Postgres YAML. Let's see if that works. Oh, has been created. Cool. Let's get pods. We do now see there's a pod called Postgres and it's in a container creating state. Obviously it takes a while. It needs to fetch the Docker image from Docker Hub. It needs to initialize the volume. It needs to do a lot of things. Then Postgres needs to be initialized and it takes a while. So that's fine. If you don't want to do enter every time, you can use this little command watch -n 1. That's for 1 second, and then add the command afterwards, and it will keep refreshing 1 time per second. It takes a long time right now. Oh, there we go. It's running. We can now copy the name of the pod, and we can say kubectl logs and the pod name. And it tells us the database system is ready to accept connections. Cool. Except for we haven't told Kubernetes how we want to connect to that. So this is not like Docker. I mean, in Docker you also need to like tell somebody that you need to map a port. But more importantly, what you actually need to do is you need to expose the port. And exposing the port is done in Kubernetes via a service. So that would be the service we need. We want to expose the port as a cluster IP. So we're going to apply our Postgres YAML again. The deployment has been unchanged. The cluster IP is now there. And that's basically very simple. It just says, it maps to our Postgres deployment. It says we want to use cluster IP. And we have the port set to 5432. All right, so that's it for that. Maybe a quick primer. What is cluster IP? What is node port? What else could we do? So basically, there's a nice article. I'll put a link in the video description as well. Cluster IP basically tells us we want to access the service from within our cluster. So if you use kubectl proxy, which probably most of you won't be using at all, you can access the service, but you won't be able to do that otherwise. That would be a kubectl proxy. But this is also just really for accessing the services within your cluster. Node port, on the other hand, basically that's the next type that we're not gonna use it. We're gonna go to the next one anyway. Node port tells open a node port on my node. So each virtual machine that Kubernetes is running on is a node. We only have one with minikube, but we would open a port in here. And last but not least would be load balancer. Load balancer is an external tool that basically routes your traffic to the services, and that's the best way you can actually do if it's an external tool, because it's independent of your cluster, but it also costs a little bit more money. But I think that's the best approach if you want to have traffic from the outside coming through. In our case, for Postgres, we don't want that. We want Postgres to be internal, hence we're gonna use cluster IP. All right. From now on, I'm gonna keep working in my terminal because we don't need the IDE right now. We're gonna use kubectl get services to double check what's here, and it will tell us, oh, Postgres is available via cluster IP, that's the IP, and via port 5432. And we should actually try that. I have pgadmin installed, and we're gonna connect to what we have in here. It says this is our cluster IP. So minicube Postgres tutorial, host is this, port is 5432, username, I think it was my Postgres user, and I think it was my password? Let me double check in my history. My Postgres user and my password. This probably won't work because this is the cluster IP. As I just said, this is the internal IP. It could have worked because minicube is kind of not a real cluster and it's internal of your server. But yeah, you see it doesn't really work. So how do you connect to your Postgres server if you actually want to try it out and like do something? It's actually possible with the so-called port forward. Don't know it out of my head, so I need to look up. There we go. I have it looked up. Basically, you say kubectl port forward service Postgres 5432 5432. I think that's your local port and that's the destination part. If you're familiar with an SSH tunnel, it's exactly the same thing. So it now tells you it has opened the port locally, and this is this one, and it has forwarded it to 5432. So if I can kill pgadmin now, no, I cannot. Goodbye. Welcome back. So if I can connect now, I'm not gonna connect to the service cluster IP that we have in here. I'm gonna connect to localhost, but I'm gonna use minicube Postgres tutorial. I'm gonna connect to localhost 5432. This port obviously needs to be free on your localhost machine. If it's not, just choose another port. And it's my Postgres user and my password. And there we go, it has connected, and you also see there is some output in here indicating, yeah, there's a connection going on. This is now helping you. You can now basically take a look what's in here and click through the database. There's nothing in the database yet. We don't have any migrations or something in there yet. So this is a completely fresh database. That's fine. This is just for debugging purpose. But it's fine because we want to just debug and see what's going on in the database. And it's something that I always like to do. I always like to do. Take a quick look in the database, see what's going on in the database, like maybe something is screwed up or maybe I have a typo or something. It's just good to have that option. So if you want to cancel that, we just Control-C that process, and now there we go. pgadmin will tell us everything is gone. Cool. With that was a long video now, so I'm gonna end this video right now, and I'm gonna ask you to go to the next part. And in the next part, we're gonna create a Python deployment that connects to our Postgres database. All right, stay tuned and see you next time.